Hey guys, today we're gonna solve Cambridge igcse Physics February 21, October, November 2023. Question 1. Which is the vector quantity? So vector quantity is that quantity that has both magnitude and direction. So density only has magnitude, not direction, so density is a scalar quantity, and mass is also a scalar quantity, and pressure is also a scalar quantity, and weight is a vector quantity. So mostly all the forces are vector quantities, and since weight is a force, so weight is also a vector quantity. So your answer will be D. Question 2. The graph shows the speed of a car traveling through a town. Which section of the graph represents a period when the car is decelerating? So when the car is decelerating, your graph will look like this. Since it's a speed line graph, your gradient will be your acceleration, and it should look something like this. So your gradient should be like this because that means it is decelerating. So that will be D. Question 3. An object reaches terminal velocity after being dropped and falling through air. Which graph shows how its speed varies with time? So your answer will be C, because as the time goes on, your speed will eventually start to decrease, and that shows in C part. In A part, you can see your acceleration is increasing constantly, but then it's 0, so that will be wrong. And in B part, your acceleration is increasing and then it becomes 0, so that's also wrong, and the same goes for D. In D part, it's already decelerating, which is totally wrong. So the only correct answer is C. It will increase a little bit and then it will start to decrease. Question 4. The table shows the mass and volume of 3 different liquids, X, Y, and Z. So you can see the mass and its volume. The liquids are placed in the same container. The liquids do not mix. Which liquid is at the top of the container and which liquid is at the bottom of the container? So first of all, you do need to remember all your formulas. So in the formula, when you have mass and volume, you have to use your density formula, which will be P is equal to M divided by V, mass divided by volume. So which liquid is at the top of the container? So the liquid that has the least density will be at the top of the container, and the liquid which has the highest density will be at the bottom. So we can calculate its density. So 120 into 200. I calculate the density using the same formula, and you can see that liquid X has the least density, so it will be at the top, and liquid Y, since it has the highest density, it will be at the bottom. So your correct answer will be A. Which moving object has a resultant force acting on it? A driver rising vertically through water at constant speed, an aircraft circling an aeroplane at constant speed. So we already know when anything goes in circle, it has a centripetal force acting on it, which also means it has a resultant force, so it will be B. A train going up a straight incline at constant speed, which is wrong. Since it's just going up, there won't be any resultant force. A parachute descending vertically at terminal velocity, that will be also wrong. You just need to remember that when anything goes in circle, there is a resultant force acting on it. Question 6. Forces are applied to 4 identical objects. The length of each arrow indicates the magnitude of the force. Which force is in equilibrium? So we know the object to be in equilibrium, both forces need to be balanced. So it means that both vertical forces, these, and the both horizontal forces must be equal. So as we can see, these 2 vertical forces are balanced, but the horizontal forces are not balanced, since this arrow is higher, so it has a higher magnitude. For B, you can see this arrow and this arrow is equal, and so is this arrow and this arrow, so it is the right answer. And as for C, you can see this arrow is higher than this arrow, so its magnitude is higher, so it won't be in equilibrium. That's wrong, and the same goes for D, since this error is a lot higher. Question 7. A sphere X collides head-on with a second identical sphere X, which is stationary. The mass of each sphere is 0.15 kg. Sphere X is traveling at a velocity of 2.0 meter per second before the collision and produces an impulse of 0.21 Newton seconds on sphere Y. What is the velocity of sphere X after collision? So we know that momentum before collision is equal to momentum after collision, and the formula of momentum is m1 u1 equal to m1 v1. And if there's more forces and if there's two forces acting after collision, you can always add them. So since their mass is constant, I'll just solve it. So 0.15 into 2.0 equal to 0.15, since we have to find its velocity, and plus, as you can see, it says it produces an impulse of 0.21 on sphere Y. So you have to plus 0.21. So when you will solve this, you will get 0.3, and 0.21 is adding here. So when it will go to this side, it will minus. So minus 2.01. Your answer will be 0.09 equal 0.15, and since it's multiplying here, it will divide. So it'll be 0.09 divided by 0.15. So your answer will be 0.6. So you can cancel out C and D, and it says opposite direction to Y or same direction as Y. So it will be B. Since our answer is positive, so it will be same direction. If it was minus 0.6, then it will be opposite direction of Y. But since it's positive, so it will be in the same direction. Question 8. A cyclist travels down a hill from rest at point X without pedaling. The cyclist applies his brakes and the cycle stops at point Y. What energy transfer have taken place between X and Y? So as you can see in position X, since it's going down the hill, it's from a height, so it will be gravitational potential energy. So it will be either A or B, so you can cancel out C and D. And since it's moving, it will be kinetic energy, and it stopped at Y, then it will be thermal energy. So it will be A. Question 9. An object of mass m falls from a higher shelf to a lower shelf. How much gravitational potential energy does the object lose? So we know the formula of gravitational potential energy, which is mgh. M is mass, g is your gravitational potential energy, and since mass and your gravity is constant, the only thing that is changing is the height. So it will be mg, and since you have height 1 and height 2, and you define the height of this, so it will be h1 minus h2. So it will be mg h1 minus h2. So it will be D. Question 10. A pump does 460,000 joules of work to raise water to fill a tank. It takes 7 minutes to fill the tank. What is the power of the tank? So we know power is energy over time, and energy is 460,000 into, since it's in minutes, we have to change it to seconds, so it will be into 60. So when you will calculate this, you'll get your answer 1095.2. So this is your answer in watts, but all the options are given in kilowatts. So when you will change your answer into kilowatts, so you can just divide it by 1000, and then you'll get your answer 1.09, which is 1.1, and your answer will be A. Question 11. The water in a swimming pool exerts a pressure at the bottom of a pool. Which graph shows the relationship between the pressure exerted by the water and the depth of water in the pool. Assume density of water is constant. So we know that as deep we go, pressure increases. So we know that depth of the water and pressure is constant, so it will be C. So there are some conditions about pressure that you do need to remember. Depth and pressure are constant, and pressure and volume are inversely proportional. Question 12. How can a gas be compressed easily into a smaller volume? So your answer will be A. The particles are far apart. So since the particles are far apart, it's a lot easier to compress them into smaller volumes. The particles do not attract each other, which is wrong. The particles move randomly. They do move randomly, but it's not the answer that they can be compressed. So it's wrong, and D is also wrong, since their volume cannot be. A gas is contained in a cylinder by a movable piston. The gas is heated so it expands at constant pressure. How is the force of each collision of a gas particle when the piston affected, and how does the frequency of collision between the gas particles and piston changes? As the particles are heated, your particle will have more collision, they will move with much greater force, so they will apply more force. So your force will increase, so you can cancel out C and D. But as it expands, your area will increase, so your frequency will decrease, so it will be A. On a warm day, a carton of fresh milk is covered with a wet cloth. Why does this help to reduce the temperature of the milk? Some water evaporates from the cloth, so the remaining water becomes cooler, which is correct. Some water will evaporate from the cloth, and some water will become cooler because some particle will escape, and the remaining particles will become cooler. Question 15. A chef heats some water in a pan on a hot plate. The temperature of the water rises by 10 degrees in time t. She then puts the same volume of oil in an identical pan on the same hot plate. The specific heat capacity of water is 2.5 times that of water, and water is 1.5 times denser than oil. What is the time for the temperature of the oil to rise by 10 Celsius? So this is a hard question. So for these type of questions, you do really need to remember your formulas really well, since you have to not only use one formula but a lot of formulas. So as you can see, the first thing I'm seeing is the specific heat capacity. So I'm gonna write the formula of specific heat capacity first. Q equal, I wrote my formula, energy, mass, specific heat capacity, and change in temperature. And it says what is the time for a temperature. So as you can see in this whole formula, we are not getting any time, so you also need to use another formula. So as you can see, this Q is energy, so we can write E equal to mc theta T. So you can also write that it's same, it's still energy, and we know that energy is equal to power into time. So this is another formula we can also use. So I'm just looking at the formula, like I used specific heat capacity, but then I noticed that there is no time. So now I'm just finding any missing value or any other formula I can link this up. So we have the energy equal power into time. So we can arrange this formula like this. Power into time is equal to mc theta t. Nothing has changed, it's still the same. And you can see that we have to find time, and we also don't have our power. So now we can see that we have the specific heat capacity, we also have the time. The specific heat capacity is 2.5, and the time rises by 10 degrees, but we don't have the mass. So now we have to think again that which formula can have mass in it. So then you have to read your question again. It says that the specific heat capacity of water is 2.5 times than that of oil, and water is 1.1 times denser. So there's denser, it means density. So when there's density and mass, there's one formula which is equal to density equal to mass divided by volume. Mass divided by volume. So I can rearrange the formula to get mass. Mass equal by density into volume. So now so instead of my mass here, I'm gonna put this. So I'm just gonna modify this formula now. P into T equal to, instead of mass, I'm gonna put this. MV C theta T. So this is my modified formula now. And as we can see, this question is even harder because you are technically working with ratios also, since it says 2.5 times that of oil and 1.1 times denser than oil. So you're kind of working also with your ratios. So you can do, so this line is pretty important in your whole question. So as you can see, the specific heat capacity of water is 2.5 times that of earth. So it means that your specific heat capacity of water is 2.5 more than of oil. So specific heat capacity of water, specific heat capacity equal by CO, specific heat capacity, and O is oil. And as you can see, the question says is 2.5 times that of oil. So specific heat capacity of water is equal to 2.5 times of specific heat capacity of oil. Second, it says water is 1.1 times denser than oil. So again, water is 1.1 more denser than oil. So again, density of water equal to density of oil, and density of water is equal to 1.1 density of oil. So these are my both ratios. So I just took these ratios just from the question. So now I've got my modified formula and my two ratios. So now I can actually solve the question further. So I'll just copy this again. And this is for water. P into T is equal to density of water into volume of water into specific heat capacity of water into 10. So it'll be PT is equal to 1.1 density of oil into volume into 2.5, this one, 2.5 times capacity of oil and your 10. And now for this is the water one. This is for water. Now for oil, power into, so you usually put time, but since that is what we have defined, so I'm just gonna put an X here, equal to power density of oil into volume specific heat capacity of oil into 10. And now we have these two formulas, and I'm just gonna rearrange the formula. And I'm just gonna rearrange the formula in ratios so I can cancel out the similar values. So P X equal to PT. So I'm just rearrange the formula. I'm taking this side to there. I'm just making the ratio so I can cancel out the same values. Equal to, and this whole side will divide by this side. So you can cancel out the power, the density of oil, specific heat capacity. So now I'm just gonna cancel out the like terms. This one, this, and this. Specific heat capacity. So as you can see on this side, nothing is left, and here x and t is left. So it will be x into divided by t is equal to, since nothing is left there, I'm just going to put 1. 1 divided by 1.1 into 2.5. And now I'm just going to cross multiply to get my x. X is equal to t divided by 1.1 into 2.5. X is equal to t into 2.75. 1.1 divided 1.1 multiplied by 2.5 is equal to 2.75. That's just what I wrote here. And when you solve this, so I just took my temperature and it came here, so it's dividing here, so when I will come here, it will just multiply. So when I will solve this, I will get x is equal to 0.36 t. So your answer will be A. This is a lot of working for 1 mark, and what makes this question even harder is that you have to use a lot of formulas, and there are also ratios, and you also have to rearrange your formula. But yeah, this is a pretty hard question, even for me, but yeah, that's how you solve this question. The diagram shows the view of a room heated by a radiator. The arrow line from x to y is the part of the convection current in the air, which were about the air temperature and the air density at y and x. At x and y is correct. So as you can see in y, your air is going down. So when anything goes down or moves down, it means your density is higher. And as you can see in x, it's going up. And as you can see in x, it's going up, so it means your density is lower. And when your density is higher, your air temperature will be lower, and that same goes for when your air temperature is higher, your density will be lower. So you can see in x, it goes down, so your air density will be higher. So you can cancel out D and A. And as you can see, your air temperature will be higher at x, since your density is lower at x. So it will be B. Question 17. Two men, P and Q, stand close to a gap in a wall, as shown. Man P cannot see man Q, but man P can hear man Q speaking. Which statement explains this? Light waves do not deflect at all because they are electromagnetic waves. That's wrong. Light waves do deflect. Light waves have a range of frequencies, but sound have only one frequency, which is also wrong since light does not have one frequency. Sound waves are of a higher frequency than light wave, which is wrong. Sound waves deflect a lot because their wavelength is a similar size to the width of the gap, which is correct. Question 18. Which quantities relating to a wave on the surface of water can both be measured in meters? So in amplitude, you can measure amplitude, but you can't measure frequency since it is in hertz. So you can cancel A and D. And also you can't measure wavelength. And you can't also measure wave speed, so it will be B. Question 19. The diagram shows a part of a wave diagram that demonstrates the formation of a visual image Y of object X by a converging lens. One ray from light from X is shown approaching the lens. Which row shows the direction of this ray as it leaves the lens? So as you can see, your ray X is paler, so when it will come from the lens, it will go through the focal point. So these are some conditions of light diagrams you also do need to remember. So it will be A. Question 20. The ray of light is reflected by a plane mirror. Which ray shows the angle of incidence and the angle of reflection? So this is your normal, and this is your incidence, and this is your reflection. So your angle of incidence is between the incidence ray and the normal, so this and this. So it will be C.